What's up, everybody? This is Coach Sharf. Welcome back to my notes videos. And today we are going to continue talking about imaginary numbers, particularly what happens when I raise the imaginary number I to certain exponents. So let's get started. This video should hopefully go pretty quick. Of course, y'all can pause it at any time to copy down anything you need to. All right, so we're talking about powers of I. Again, I is our imaginary number. So we know I is equal to the square root of -1. When I say powers in math, again, we're talking about exponents. So we're going to raise I to certain exponents and explore what that does. We know I is equal to the square root of -1. We can raise I to higher exponents and change the value from the square root of -1. So when I say higher exponents, a lot of y'all are probably saying, well, what do you mean, Coach Sharf? We hadn't talked about I with any exponents before now. Well, not explicitly, but I did tell y'all I is, even though I has a value, the square root of -1, we treat it pretty similarly to variables. We could kind of treat it like a variable. So if I have the variable x, it's the same as x to the first power. I is the same way. I is really the same as I to the first power, which is still equal to the square root of -1. Okay, so if you see I or I to the first, it's still the imaginary number still equal to the square root of -1. So we're mostly going to use this relationship, okay? But it's I to the first, the same thing, still represents the square root of -1. So what happens when I, myself, raise I, the imaginary number, I put in quotations because capital I raise lower I looked kind of funny to me. What happens when I raise I to a higher power than 1? So this is where you might want to get a different color if you're writing this in regular pencil, because I'm about to use red. Okay, again, you can use whatever color you want. I'm gonna put I squared here. Well, if I'm squaring one side, I'm still talking algebraically. So if I square one side, I got to square this side. All right. And I'm going to put it in parentheses. Why am I going to put it in parentheses? Because if I don't, if I just go to put a 2 on there without putting in parentheses first, a lot of y'all, if you're in a rush, you might get a little confused, might stick your 2 down there, which is not what I want right now. Okay. So we're going to leave like this. So when I'm squaring and square rooting something, squares and square roots are opposites, okay? It's like if I added 5 to something and subtracted 5 from something. Again, if I'm talking squares and square roots, if I started with, I did 4 and then 4 squared and then took the square root of it in class. Let's do the opposite here since we're really doing the square root first. So if I had 9, okay, if I was taking the square root of 9, all right, that is 3. Okay, that is 3. So you can almost write equals 3 out there. And then if I square it, so square root of 9 is 3. And then if I square that, I get back to 9. So again, essentially the square and the square root canceled each other out. And I finished where I started. So algebraically, we can cross out the square and the square root. I'm left with the -1 and I still have I squared over here. So I now have this relationship I squared equals -1. -1 is a real number. We talked about it falling into our real number set, in particular subset for integers. So -1 is a real number. I can use it. That is primarily why I even need to talk about imaginary numbers to begin with, because I squared does equal -1. Okay. It's right there in our main standard that we're talking about, and one of the other standards too, the standard we're going to talk about with our next lesson, complex numbers. Okay, let me try to share that real quick just so y'all can see it. I don't have it quite pulled up. Okay, I have Canvas up now. Here we go. That's what I was looking for. Come down to my algebra 2 and my math, my Newton County School System Secondary Mathematics page. You know, we have classes in here just like y'all do. There's that. Unit 1 quadratics revisited. As I told y'all that this is titled in the previous video. All right, we skipped concept 0. Here's concept 1. Perform arithmetic operations with complex numbers. NCN 1. Understand there is a complex number I. Again, technically I is a complex number. All complex numbers have this form, A plus BI. We'll talk about that next week. So I falls into this category if A is 0 and B is 1. Normally we just refer to it as the imaginary number, but technically this is correct. Anyway, understand there's a complex number I such that I squared is equal to -1, what we just talked about. Every complex number has the form A plus BI where A and B are real numbers. It's also in this one, use the relation I squared equals -1 into commutative, associative, and distributive properties to add, subtract, and multiply complex numbers. So we'll explore what a complex number is next week. The commutative and associative properties basically work out to combining like terms. The distributive property is used when I'm multiplying complex numbers. This A plus BI kind of looks like a binomial, right? So, you know, X plus 2 or X minus 5 kind of looks like that. So we can use the FOIL method or the box method to multiply those. But again, that's going to be the next video. You know, if you're watching this over the weekend, that's going to be this upcoming week. But let me go back to the active board. All right. So we can go higher than 2 with our exponent, and we use rules of exponents to figure out our values, particularly the rule of exponents that is called product of powers. I probably do not recall what this is off the top of your head. I'm about to show you. Let me slide back up because I went through kind of quick. You can pause right here to write this down if you want. We're going to have I cubed, I to the 4th, I to the 5th, which you do need to write. The example I'm about to do, I'm going to do a different color. I'm thinking yellow. You don't have to write the example I'm about to write, but it is something that should be familiar. Okay, so I'm going to come write it down here over in the corner just as a refresher. I'm going to do, I switched that to yellow. There we go. X squared times X cubed. If I ask you what is X squared times X cubed, when I'm multiplying the same base that both have exponents, I got to add the exponents to give me X to the 5th. Okay, I add the exponents to give me X to the 5th. This is not X to the 6th. If we want proof of that, we know X squared is X times X. This multiplication symbol comes down here. X cubed is X times X times X. So I now have 1, 2, 3, 4, 5 X. So this is X to the 5th. Okay. Again, you don't have to write that. I'm going to leave it just because it's going to take a little time to erase it. All right, let's look at I cubed. So we're going to use that rule we just talked about, but kind of in reverse. We're going to break up I cubed into I squared times, I was about to do minus for some reason, I squared times I to the 1st. 2 plus 1 gives me my 3. We just learned on the previous slide, I squared is equal to -1. I'm going to substitute. I squared is equal to -1, so I substitute. Times I to the 1st. I said on the first slide, I is equal to I to the 1st is equal to the square root of -1, but we're primarily going to use this relationship. So I to the 1st, we substitute with I. So I to the 1st, we substitute with I. -1 times I is going to be -1I. Of course, I don't actually have to write the 1, so it's just going to be -I. So I cubed is equal to -I. I to the 4th, I'm going to use I squared times I squared. I could use I cubed times I to the 1st. I would have to do some extra math. I would eventually get back to the same answer. But I'm not asking y'all to prove it. I just need you to know I cubed is equal to -I. You don't have to prove it to me. So this is just showing y'all why it's correct, but you don't have to memorize this proof. Okay. I squared is equal to -1 as we discussed. I squared is equal to -1 as we discussed. -1 times -1 is +1. So I to the 4th is equal to +1. Again, bring it down here. If you needed to pause at any point, you can pause to finish writing it down before I move on to x to the 5th. So x to the 5th, I'm going to do I to the 4th times I to the 1st. All right. I to the 4th, we just said is 1. I to the 1st, we revisited it out up here. We know it is I. 1 times I is 1I, or just I. All right, so I to the 5th is I. So we've got, I'm trying to think how this is going to reflect coming across the screen. I might need to do it this way. Okay. I to the 1st is, back up my hand, turn it over. All right, I to the 1st is I. I squared is -1. I cubed is -I. I to the 4th is +1. So I've got I, -1, -I, +1. I to the 5th comes back to I. So what do you think I to the 6th is? It's -1. I to the 7th is -I. I to the 8th is +1. And we go back and keep going. It's a cycle. Okay. It's a cycle. So what's that cycle look like? Right here. I to the 1st is equal to I squared, -1, I cubed, -I. I to the 4th, 1. Cycles every 4 exponents. So if you have, I don't know, let's say I to the 22nd power. Okay, you can count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I to the 22nd would be equal to -1. Okay. If I ask you on a test, what is I to the 35th equal to? Again, a little bit bigger of a number, but y'all could probably sit there and count out 35 even if it takes you a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So I to the 35th is equal to -I. What if you have a much larger number though? Say I to the 223rd power. You're not going to sit there and count to 223. Okay, so for smaller numbers, we can count it out. If you have a bigger number, this rule actually applies to the smaller numbers as well, but the smaller numbers we can count out, it's a little easier. But for any number, but particularly larger numbers, if I don't want to count it out, it's going to take too long. So what do? I have a large exponent, something I don't want to count out. Example, I to the 137th power. I divide my exponent by 4. The decimal on my answer will let me know the value. Okay. So think about when I divide by 4, think about money. If I split a dollar up into 4 quarters, okay. We either got 25 cents, 0.25, 50 cents, 0.50, or just 0.5, 75 cents, 0.75, or a whole dollar, 1.00. So no actual decimal. Okay. So it's the same idea here. Really, it would be much easier if we said divide by 4 and whatever your remainder is. Because if you have a remainder of 1, it's the same as I to the 1st, remainder of 2, same as I squared, remainder of 3, same as I cubed, no remainder is I to the 4th. Most of your calculators, you have to go into a certain mode to get a remainder if they even do that. So it's just easier to talk about it in terms of the decimals. Okay. So I would divide 100, where's my regular calculator? 137 divided by 4. Punching in here, I would get 34.25. Okay. So my decimal when I divide my exponent on I, if I get 0.25, it's equal to I to the 1st, so it's equal to I. So if I asked you on a test, what is the value of I to the 137th power? Your 4 answer choices would be I, -1, -I, +1. Not necessarily in that order, might switch the order up on you just to see if you're paying attention. but I would be my answer. Okay. My decimal is 0.5. It's the same as I squared, so the value would be -1. I divide my exponent, my decimal is 0.75. Same as I cubed, so the value would be -I. No decimal, divides even. I to the fourth, my value would be 1. So the thing that you need to know how to do is this. Okay, I'm going to give you the chart on a quiz or test. So you will have this. Okay, you do not have to. You need to know I to the first is the square root of -1. You need to know I squared is equal to -1. You don't necessarily have to memorize I cubed is -I to the fourth is 1. I will give you that. Okay. What you're going to have to do is either, if you have a smaller exponent, to count it on your chart, or if you have the larger exponent, to divide your exponent. I didn't actually put 4 on here. When I divide my exponent on I guess I should have put by 4. I don't know how many y'all are actually go back and watch this. By 4. So I'm going to have 0.25. You need to know 0.25. If I divide, if I divide and my decimal is 0.25, it's equal to I. If I divide and my decimal is 0.5, it's equal to -1. If I divide, it's equal to my decimal is 0.75, it's equal to -I. If I divide and there's no decimal, it's equal to 1. So this is the part that y'all are going to have to know. Okay. And you don't have to memorize this. You just know, you have to know how to use it, which is either counting it out or dividing your decimal, your exponent by 4 and knowing which decimal applies to which of these. Okay. So there's that no video. I will have an included assignment with this for y'all to do. Again, probably be about 16 to 20 problems. I'm just going to ask you, what is the value of I to the 204th power? What is the value of I to the, I can go higher because all you're doing is dividing by 4 in your calculator. I can ask you, what's the value of I to the 10,723rd power? Divided by 4, whatever your decimals. Okay. That would actually be only out of my head. So the 10,000 would be 2,500. 73 divided by 4 would be 72.25. So 2,572.25, which would be I. But anyway, so there's that. If y'all got any questions, as always, send me a message on Remind. If everybody's good, I'll see y'all in class.